So here, today our goal is going to be to begin to apply multiple properties to simplify expressions. So our goal will be to be able to simplify completely expressions like this. And we'll even get to these exact ones maybe if we have time. So how could we simplify this completely without a calculator? How can we simplify this completely without a calculator? And again, simplifying completely, meaning that we don't have any exponent left when we're done with it. So today we notice at least two new things here. One is that now we have fractions in the exponent, and we have these weird things here, which you may know are called roots. So what are we going to do? So first we need to talk about roots and fractions. So when we have something raised to a fraction exponent, and actually we'll keep our explanation a little bit limited today so that we don't say too much all at once. Let's just look at a couple examples here. 2 to the 1/2 power, 2 to the 1/3 power, 2 to the 1/4, to the 1/5, to the 1/6. So what do these become? 2 to the 1/2 becomes square root of 2. This would become cube root of 2. And as we fill these out, see if you pick up on the pattern. So 2 to the 1/2, square root of 2, 2 to the 1/3, cube root of 2, 2 to the 1/4, fourth root of 2, fifth root of 2, sixth root of 2. So when you have a fraction that's just 1 over something, that number just goes in front of the radical, the root symbol. And again, or we haven't mentioned this necessarily, but this symbol is called root or radical. And there's some number here. We can just call it n. So what do these root symbols mean? What does this radical symbol mean? Well, let's say we have square root of 4. Square root, you may be familiar with. It's saying what number multiplied 2 times gives you this number on the inside. What number multiplied 2 times gives us 4? That'd be a 2. How about cube root of 4? That's saying what number multiplied 3 times gives us 4. And that one's not going to work out nicely, but let's say we had cube root of 8. That's saying what number multiplied 3 times gives us 8. And that's going to be 2, because 2 times 2 times 2, 2 multiplied 3 times is 8. How about fourth root? What do you think fourth root means? That's what number multiplied 4 times gives you this. So fourth root of 81, and it may take you a while to get familiar with some of these. You may have to do some guess and check work off to the side, use a calculator, things like that. Fourth root of 81 is going to be 3. Why? Because 3 multiplied 4 times gives us 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So cube root of 8 would be 2, fourth root of 81 would be 3, and it goes on and on. If you had the 10th root of some number, that's saying what number multiplied 10 times gives you this number. So let's look at maybe 1 or 2 more. Let's say we had the let's say we had 16 to the 1/4 power, and let's say we have 27 to the 1/3 power. So let's try these together. So we know that anything to the 1/4 power becomes a fourth root like that. So this 1/4 literally becomes this. And then we fill in the 16. And this is saying what number multiplied 4 times gives us 16. And again, you may need to stop and try a couple things out. If you're multiplying a number 4 times and you're going to wind up with 16, that number is probably going to have to be pretty small. So let's start with maybe 2. 2 multiplied 4 times, let's see what we get. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we found it. 4th root of 16 is 2. So 16 to the 1/4 power equals 2. About 27 to the 1/3. Let's actually go ahead. Let's pause the video here and let's try that as a practice. So go ahead and pause the video and try this out. All right, let's have a look. So 27 to the 1/3 power, we know that the 1/3 power just becomes a cube root. Whatever number's on bottom just goes on the outside of the root symbol. And we have a 27 inside. So this is saying what number multiplied 3 times gives us 27. So what number is that going to be? It's going to be 3. 3 times 3 times 3 is 27. 3 times 3 is 9, times another 3 is 27. 27. So 27 to the 1/3 power equals 3. So that's something we're going to need to know going into this. Also, one thing we want to review from yesterday, a tool that's going to help us, or a concept, is when we talked about this, when you have a product raised to a power and a quotient raised to a power. So first case, you have parentheses and inside you're multiplying things. In second case, we have parentheses in the inside, we're dividing things. So in the first case, the exponent goes to each thing being multiplied. So this would be a to the m times b to the m. In the second case, it goes to the things being divided, both of them. So we'd have a to the m over b to the m. So this is going to be important for solving those problems we were looking at the beginning. So let's look at one of those problems we were talking about, or a problem like those ones. So let's say we have 18 to the 1/2 power times 2 to the 1/2 power. Our goal is to simplify this so that we don't have any exponents without using a calculator. So based on what we were just doing, our immediate idea would probably be to turn it into something like this: 18 square root times square root of 2, which is a good idea. And in some cases, that may be the best way to go. But here, if we notice, and we can write in the 2's here, again, when it's a 2, when it's square root, so 1/2 power, you don't technically need to write in the 2. You need to write it in for every other number. But if there's no number there, it's implied that it's a 2. So we'll just leave our 2 there. So this is saying what number multiplied 2 times gives us 18. And here we run into a problem. Same thing over here. What number multiplied 2 times gives you 2? Because these numbers aren't perfect squares, the actual numbers would be numbers with decimals that go on forever. They'd be irrational numbers. Because if you think about it, if you do 4 times 4, that'd give you 16. That's too low. And then if you go up 1, 5 times 5, that's 25. 18 somewhere in the middle, so it'd really be 4 point something. We don't want to deal with those decimals. So if we run into a scenario like that, we might want to back up and try something else. So from here, what's a different approach we could take? And we're going to use what we were just talking about, where we said if you have a times b raised to the m power, that becomes a to the m times b to the m. So basically, if you notice, this is just like what we have here. something raised to a power times something else raised to the same power. These are both m, these are both 1/2. So we just tried to start from here and simplify, and that didn't work. So what if we go backwards? What if we turn this back into this format and then see if that somehow opens up an opportunity, which is going to be what we try in a lot of these problems with exponents, is to rearrange things and see if it opens up any opportunities. So how could we go from here back here? If you notice what's happening going backwards, you're saying, okay, they both have the same exponent. If they both have the same exponent, we can pull it out and put it on the outside so that just a and b are left on the inside and the exponent, the m, is on the outside. So if we apply that to our problem up here, a and b are going to be left on the inside. That's 18 and 2. And the exponent, the m, in this case 1/2, is going to be on the outside. So basically the idea is if they have the same exponent, you can just pull it and put it on the outside. And now what's going to happen? What can we do from here? Well, now this 18 times 2 is just on the inside of the parentheses, the exponent's on the outside. So we're free to go ahead and multiply these two things on the inside. 18 times 2 gives us 36, still to the 1/2 power. And now that we've made a little adjustment, let's try turning this 1/2 power back into the square root. Now look what happened. 36 is going to be a perfect square. What number multiplied 2 times gives us 36? That's going to be 6. So there we go. We've simplified to the point where we have no exponents left. That's going to be our final answer. Let's look at another one. Let's say we have 54 to the 1/3 power times cube root of 1/2. So this one looks pretty ugly. We're taking a cube root, which is already complicated enough, of a fraction. What are we going to do here? Well, you want to sort of start by just looking at the problem and seeing if you can come up with, if anything stands out. And the thing that we notice here is that here we have 1/3 power, here we have cube root. If we remember, those are the same thing. So if we're thinking along the lines of what we did on the last problem, we could do something like this. We could leave this one as 54 to the 1/3 and change this one into 1/2 raised to the 1/3 power. Now, if you notice, they both have the same exponent. Remember, we can pull that out and put it on the outside. So we're going to have on the inside the a times b, 54 times 1/2. And on the outside, we have our exponent of 1/3. Now again, we're free to multiply whatever's on the inside. 54 times 1/2, that just means 1/2 of 54. What's half of 54? That'd be 27. And now we can turn this 1/3 power back into a cube root because we've changed things. Maybe something's going to work out, and it turns out that it will. So we have cube root of 27. This is saying what number multiplied 3 times gives us 27. That's going to be 3. That's 3 times 3 times 3. 3 multiplied 3 times gives us 27. So our answer is 3. There's no exponent left. That's our final answer. So we were able, without a calculator, to turn this big ugly thing into that there. So let's look at one more together. Let's say we have 4th root of 4 times 4 to the 1/4 power. So is there a number, a nice clean number that we can multiply 4 times to get a 4? No. 1 times 1 times 1 times 1 would give us 1. 2 times 2 times 2 times 2 multiplied 4 times would give us 16. We jump right past 4, so it'd be some decimal. So that's not going to work taking the fourth root. So let's try what we were doing. Let's rewrite this as 4 to the 1/4 power. We'll leave this one as 4 to the 1/4 power. And there, at some points, there may be multiple steps you could take. Like if you notice something, these both have the same base, they're 4s. So you could add the exponents here. But let's continue on how we were doing it before. We noticed they have the same exponent, so we can pull it to the outside. So we were just left with the 4 times 4 on the inside. And on the outside, we have the 1/4 power. We're free now to multiply what's on the inside. 4 times 4 is 16. Now let's try turning the exponent back into a root and see if it works out nicely. 4th root of 16. And this is saying what number multiplied 4 times gives us 16. That's going to be a 2. 2 times 2 times 2 times 2 is 16. So 4th root of 16 is 2. So let's try a practice. And let's maybe squeeze it in the corner over here. So you can reference this if you want to. This is practice number 2. And let's say we have 50 to the 1/2 power times square root of 2. Let's go ahead and pause the video and try this one out. Same thing we've been doing. All right, let's have a look. So 50 to the 1/2 power times square root of 2. So 2 is not a perfect square. So trying to take the square root of 2 is probably not going to help us. It's going to be a messy number. So let's start by doing what we have been doing, because we may notice that square root is the same as power of 1/2. So if we're going to rewrite this square root of 2 as 2 to the 1/2 power, now they have the same exponent, which is something that can help us. Because if they have the same exponent, we can pull it out. We'd be left with 50 times 2 on the inside and the 1/2 on the outside. We're now free to multiply the inside. 50 times 2 is 100. And now let's turn that 1/2 power into a square root. Square root is saying what number multiplied 2 times gives us 100. That'd be 10. 10 times 10 is 100. So 10 is our final answer. Let's look at one last one together. Or rather, let's try it as a practice. Last practice. What is this, number 3, I think? Practice number 3. Let's say cube root of 4 times 2 to the 1/3. So let's pause the video and go ahead and try this last one out. Okay, let's have a look. So cube root of 4 means what number multiplied 3 times gives you 4. And that's not going to work out nicely. 1 times 1 times 1 would give you 1. 2 times 2 times 2 would give us 8. So what number multiplied 3 times is going to give us a 4? It'd have to be between 1 and 2. But it'd be some decimal. So that's not the path we want to go down. But if we notice, like before, we see this one has a 1/3 as an exponent. We know that cube root is the same thing as 1/3 power. So let's go ahead and rewrite this cube root as the power of 1/3. When they have the same exponent, we can pull it out. We're left with 4 times 2 on the inside. 1/3 is up here. We're free to multiply the inside now. It's going to be 8 to the 1/3 power. And now that we've changed things, let's try turning this exponent back into a root. And this is saying what number multiplied 3 times gives us 8. It's going to be 2. It's 2 times 2 times 2 is 8. So 2 is our answer. So from here, we'll go ahead and stop the video and move on to classwork.